So now let's talk about some ways of making more robust estimates of the central value and the spread of the data. So robust meaning let's look at some methods that are stable or aren't very sensitive to the numbers in the data or even the number of values in the data. So first considering central location. And let's go back to our sandstone densities. That was in, I guess that was the first video. So if we look at the mean density of our sandstone, plus and minus the standard deviation of our sample, we get 5.24 plus and minus 7.8. Remember there was that 23 value of density, and that contributes to a large standard deviation. So if we toss out the outlier, and our outlier again was that value of 23. If we toss that out, we get rho bar plus and minus s equals 2.28 plus and minus 0.05. Okay, so if we just take that one out, then we get a very different estimates for the central location and the standard deviation or the variation. And so using the mean and standard deviation, those are not necessarily very robust estimates. So we would say that we can say that the L2 estimate for example, for the standard deviation, for the L2 estimate for the central location has a break value or a breakdown value of just 1 out of n, or just 1 over n. So just 1 out of n values was enough to lead to large change in the L2 estimate, which was the mean. However, if we look at the median, we get 2.30. And if we toss the 23, which we assume is a typographical error by whoever entered the data, we get 2.28. So the value didn't change very much. And it's still within, well, a standard still within, I guess, S of the original value. So the median has a what's the break point or breakdown value for the median? So we can remove as much as half the points on either side of the median on one side of the median before we significantly change this measure of the central value. So the median is the more robust estimate of the central value. So now let's look at the spread. And one great way to take advantage of the robustness of the median is using the median absolute deviation. Or MAD, as Wessel abbreviates it. And that's equal to 1.482 times the median of the absolute deviation. And we'll use absolute deviation from the median here. Oops. So if we look back to our example, the median of our sandstone samples, or the median absolute deviation of our sandstone sample is 0.07. And this too has a breakdown value of 50%. You have to remove half of the points to change the MAD significantly. So now we talked about, well, we've seen how the effects of that bad data point, that value of 23 for the density, can affect these different estimates. Let's formally now talk about how we identify outliers. And a logical way to do that is, let's take our deviation, our measure of deviation from the central value, and divide by our measure of variation. So it's our characteristic variation that we're dividing by, and we'll call that ZI. So for example, if we used our L2 definition for our central location, Z sub L2I, then that would be XI minus X bar divided by our standard deviation. And let's look at our L1 definition for the central location, and we'll define the deviation from our median, and let's divide that by our median absolute deviation. So the strategy is to find, so let's define a cutoff. So for ZI greater than a cutoff value, then that value is an outlier. And there are, of course, what we define as outlier depends entirely on what we choose for Z cut. But let's just for now, let's say Z cut equals 3. And it turns out that a value of 3 is a very safe value to use for example, for a Gaussian distribution, a Gaussian probability distribution. So if we used this method, say for our sandstone density sample, we would get values of Z of minus 0.37, 0.39, minus 0.39, minus 0.37, 8, minus 0.37. So we're right around a third of the total standard deviation, except for this one value. The 23 value is very far, is over 2 times the standard deviation away from the mean. And the last value, if I can write, having troubles writing today for some reason. And if we used our value of z cut as we said we wouldn't see any outliers if we use the L2 value for the mean or the central location, right? If we use this value of z, none of these, including the high value, would be greater than 3. So we wouldn't identify any outliers in that case. But if we used our second definition using our robust measures of the mean, or robust measures of the central location as well as the variation, we would get 0 minus 1.35. Remember, MAD was a lot smaller, so the numbers are going to be a bit bigger here. And there'll be more positive numbers here. And that's 279.67, right? So this value, the 23 value, is clearly an outlier. I was just checking to make sure that 279 was correct, and that's correct. So this is clearly an outlier because that's greater than z cut. So this would clearly identify 23 as an outlier, and we would know that we would have a lot of suspicion that that was a data point that was of suspect.